Today we will do some numerical problems based on oscillation. Let us take first example. Question number 1. A block having mass 1 kg is fastened to we are considering the spring as massless. The spring constant is 30 Newton per meter. 30 Newton per meter. Now the block is pulled to a distance x equals to 10 centimeter from its mean position. At x equals to 0. We have to calculate the kinetic energy, the potential energy and total energy of the block when it is 5 centimeter away from mean position. Solution can be given as the block executes simple harmonic motion. Its angular frequency omega will be calculated as square root of k upon m, where k is the spring constant and m is the mass of the block. So from this we can have the values of k and m. K is given 50 Newton per meter divided by 1 kilogram, and square root of this will provide the angular frequency. So value of the angular frequency will be square root of 50 radian per second, or omega equals to 7.07 radian per second. Displacement of the mass block at any time t is given by x as a function of time equals to 0.1 cos 7.07 t. When particle is 5 semi means 0.05 meter away from mean position, the equation for displacement 0.05 equals to 0.1 cos 7.07 t, or cos 7.07 t will be equals to 0.5. Consider this equation number 1. Thus sin 7.07 t will equals to square root of 1 minus square of 0.5. That will give us the value 0.866. Let us consider this the equation number. Velocity of block at position x equals to 5 centimeter will be equals to 0.1 multiply 7.07 multiply 0.866. As we know, the value 0.1 is the maximum displacement of the particle or the block. 7.07 is the value of angular frequency or angular velocity, and 0.866 it is the value of function sine omega t. So in this way, the value of velocity will be equals to 0.61 meter per second. Hence, kinetic energy of block equals to half mv square, which can be resolved at its solution will be half multiply 1 kg mass of the block multiply square of the velocity of the block square of 0.61 square of 0.61, or you can say the kinetic energy of the block will be equals to 0.19 joule. Similarly, the potential energy of the block will be given as half k x square, where x is the displacement position of the mass block at 5 centimeter, for which we have to find out the potential energy. So here the value of the potential energy of the block will be half multiply the value of spring constant 50 Newton per meter multiply the square of the displacement, which is 0.05 meter, and finally we get it the potential energy as 0.0625 joule. Thus the total energy of the block will be sum of kinetic energy plus potential energy, that will be equals to 0.19 plus 0.0625 joule, 0.25 joule. And the total energy of the block will be conserved because it is a simple harmonic motion. We can take here another example of simple harmonic motion to solve a problem. A 5 kg collar is attached to a spring of spring constant 500 Newton per meter. It slides over a frictionless rod. Frictionless horizontal rod. Horizontal rod. The collar is displaced from its mean position by 10 centimeter and released. We have to calculate here the period of oscillation and the maximum speed of cholera. The solution of the problem will be such that the value of time period t for simple harmonic motion is given by 2 pi 2 pi multiplied by square root of m upon k, where m is the mass of the column and k is the spring constant. So here these values can be placed 2 pi multiplied square root of mass of color, which has been given here the 5 kg, and the spring constant 500 Newton per meter. This again will give the result 0.63 second. Now for the next, the maximum speed of the collar. As we know, the function of the velocity is given by as a time variant function minus a omega sine omega t plus phi. Maximum speed v maximum will be provided here as the magnitude of the velocity equation, or the function of velocity with respect to time, which is here a omega. The value of a, maximum amplitude of the displacement, 10 centimeter means 0.1 meter, multiply by the angular frequency. Its value is 2 pi upon t. So we will write it here omega's value as 2 pi divided by value of t, that can be again rewritten as 0.1 multiply 2 pi divided by 0.63, and thus the maximum speed is achieved 1 meter per second. So that is the solution for our problem. We will take another topic in our next class. Till then, good day.